Guys, welcome back to our channel QA Tech. If you haven't subscribed our channel, please do subscribe to get a notification whenever there is a new session uploaded. QA Tech is back with the second session of software testing. Before going to the second session topics, if you are interested to learn the previous session topics, so here are the list of topics covered in last session. So the topics are project and product, classical versus latest definition of quality, defect, bidding the project, PIN, and finally software development lifecycle. If you want to go through these topics once again, please go through the link provided in the description box. So without no delay, let's move into the topics going to be covered today. So today's agenda is testing techniques, levels of testing, environments and its types. Let's start with our first topic, testing techniques. Generally, when an application is given to the testing, testers use certain techniques to test the application. These techniques are called as testing techniques. There are three methods of testing techniques. They are white box testing, black box testing, and grey box testing. Let's begin with black box testing. If one performs testing only on the functional part of an application without having the knowledge of structural part, then that type of testing is known as black box testing. Usually, test engineers will be performing this black box testing. Let me explain this with an example. Suppose if there is a website named www.seominds.com needs to be tested, then developers will provide an application for testing. Then testers start the app without opening the code. That is, open the application by typing the URL and start testing the application without touching the source code. This type of testing the application is called as black box testing. Coming to white box testing. If one performs testing on the structural part of an application, then that method of testing is known as white box testing. Usually, developers or white box testers will be involved in white box testing. White box testing is also called as glass box testing. Let me explain you white box testing with an example. Suppose the application named www.seominds.com needs to be tested. The developers provide URL along with the source code. Here the testers who choose this white box testing should be bit technical to understand the code. This is how white box testing is performed. The last type of testing technique is grey box testing. It is a method of testing in which one will perform testing on both the functional part as well as the structural part of the application. Usually, the test engineers who has the additional knowledge of structural part will be involved in grey box testing. In other words, grey box testing is defined as the technique to test the software application with partial knowledge of the internal workings of the application. Grey box provides combined benefits of white box and black box testing. So the next topic in software testing is levels of testing. There are 5 levels of testing. Generally, to test an application, there will be 5 levels. Those are unit level testing, module level testing, integration level testing, system level testing, and finally user acceptance level testing. Let's begin with unit level testing. Unit is defined as the smallest part of an application. Usually the programmers are called as units. In this level of testing, each and every program developed will be tested, as well as some programs will be combined and will be tested by the white box testers. As the white box testers are testing the programs, this level of testing is called as white box testing. Suppose if you see the image over here, unit 1 which is developed by the developer 1 and it will be tested by the developer 1. Similarly unit 2 and similarly unit 3. So this is how unit level testing is performed. And let me explain you this unit level testing with a simple example. For example, in the left side you can see a login page which was developed by developer 1. So login page contains a username, password and a login button. And in the right you can see another page, that is home page, which is developed by developer 2. Home page contains home, profile and history tabs, and within the dashboard you can see welcome QA tech and a logout button. Suppose login page is developed by unit 1, this is called as unit 1, and home page is developed by developer 2, this is called as unit 2. So individual developers developing particular part is, this is called, and testing this only this part is called as a unit testing. So the next level of testing is module testing. Module is defined as a group of related features to perform a major task. In this level, the module will be released to the testing department and the test engineers will be testing the functional part of that module. As the functional part is being tested, the module level testing will fall under black box testing. So here module can be defined as unit 1, unit 2, unit 3. So such units together is called as module. Let me explain module testing with a simple example. As defined in the unit testing, I have given an example that login page is developed by developer 1. This is a unit 1. And home page is developed by developer 2 and call it as unit 2. So what will happen is, for the module testing, login page and home page together will be given as a testing to the tester. So this is called as a module. So here we can understand the group of units together clubbed and given to the testing. This is called as module level testing. The next level of testing is integration testing. Generally, interface is a program which is used for linking the modules. In this level, the developer will be developing the interfaces in order to integrate the modules. Those interfaces will be tested in order to check whether they are apt or not. As some programs are being tested, integration level testing will fall under white box testing. So here you can see, in the previous example I have explained a group of units is nothing but a module. Here a group of modules is nothing but a integration testing. So let me explain integration testing with an example. Suppose there are 3 modules, that is login module, email module and delete module. So I can say that logging into the application, email is nothing but sending an email and then deleting the email. This complete thing is given to the testing. So testing this complete set is called as a integration testing. In other words, I can simply say that when I log in as a user as QA tech, the emails of the QA tech should be loaded, and whenever I send an email, the email should be sent from the QA tech user. And whenever I delete an email, I should be able to see the deleted email should be there in the trash of the QA tech user. So this complete thing, like login should be apt with email and email should be apt with delete. So this complete set of testing is called as integration testing. Types of approaches followed by developers while integrating the modules are Big Bang approach, incremental approach. Again, In incremental approach, there are three types of approaches. That is top-down approach, bottom-up approach, and hybrid approach. Let's start with Big Bang approach. Generally, Big Bang approach is an integration testing where all the modules are integrated together at once and tested. If software testers need to test entire software at one go, then this type of testing is performed. For example, here I can say, suppose if the software tester want to test the application, all the tester has to wait until all the modules are developed. Once all the modules are developed, then only the tester can test the application. This type of testing is called as Big Bang approach. Next, coming to incremental approach. After unit testing is completed, developer performs integration testing. It is the process of verifying the interfaces and interaction between the modules. While integrating, there are lots of techniques used by developers, and one of them is incremental approach. In incremental integration testing, the developers integrates the modules one by one using stubs or drivers to cover the defects. This approach is called as integration testing. To, to the contrary, Big Bang is one other integration testing technique where all the modules are integrated in one shot. So let me explain the top-down approach. In this approach, the parent module will be developed first and will be integrated to the corresponding child modules. So let me explain the term stub over here. While integrating the modules in top-down approach, if at all any mandatory module is missing, then that module is replaced with a temporary program known as stub. Here in the right side in the image, you can see suppose M1 module is developed and the topmost M1 module is developed and the rest all modules are not yet developed. And after some time, the other modules, the dependency modules, which are in blue color, are also developed. And the modules which you see in the pink color are not developed. Then what we'll do is we'll simply replace that particular modules with the stub, and so that the entire module is ready and we can start testing this. This is called as top-down approach. Now, coming to bottom-up approach. In this approach, child modules will be developed first and then integrated back with the corresponding parent module. While integrating the modules in bottom-up approach, if at all any mandatory module is missing, then that module is replaced with a temporary program called as driver. Suppose here you see the bottom, all the blue color modules are developed. These are called as child modules. These are all developed, and the parent module, which is in pink color, has not developed. Then what we'll do is we'll replace that pink color module, I mean to say the parent module, with the driver. So this is called as bottom-up approach. And the next type of approach is hybrid approach. It is a mixed approach of both the top-down and bottom-up approaches. Now, coming to the next level of testing, that is system level testing. In this level, the test engineers will perform different types of testing on the system. One among those very important type of testing is system integration testing. Apart from this type of testing, some other types like load testing, performance testing, stress testing, usability testing, etc. will be conducted in this stage. As the black box testers are conducting the testing, the system level testing will be under black box testing. So, system integration testing is nothing but it is a type of testing in which one will perform some actions in one module and check for the reflections in all the related modules. So I'll explain you this with an example. So before going to the example, let me explain you in other words. So system testing is nothing but it is a combination of functional testing and non-functional testing. So functional testing is nothing but checking the functionality of the application, like black box testing, requirement based testing, database testing. These all testings comes under functional testing. Whereas non-functional testing is nothing but checking the security of the application, checking the load testing, stress testing, performance testing. This is all about non-functional testing. So coming to an example of software testing, suppose there is a website named Amazon, and what I'll do is a customer has ordered an iPhone. In the left you can see customer ordered an iPhone 10. So before ordering the iPhone, there should be in the database, there should be 10 iPhones. Total availability iPhone should be 10 within the database. Next, what we have to do is the customer will order an iPhone, then he will pay for the product. So once he pays for the product and the product is shipped, then the items in the database should be 9, so that the next user who logs in and views and search for the iPhone 10, he should be able to see 9 phones as one got already purchased. So this is all the impact of a website with the database. So this is all about system testing. So let me explain you with the user acceptance testing. So user acceptance testing is nothing but the test engineers will check the user desired areas in the presence of user in order to make him accept the application. As the test engineers are performing the user acceptance testing, it will fall under black box testing. So we call user acceptance testing as UAT. So the last topic in today's session is environment and its types. Environment is a combination of presentation layer, business layer, and database layer which can hold the presentation logic, business logic, and database logic. Or environment is defined as a group of hardware components with one software where we can install the presentation logic, business logic, and database logic. Types of environments. Generally, there are four types of environments. The first one is standalone or one-tier environment. The second one is client server or two-tier environment. The third one is web or three-tier environment. The last one is distributed or entire environment. So let me explain with the first one, that is standalone. In this environment, only one tier, all the three layers, that is presentation layer, business layer, and database layer, will be present in that layer only. If at all the application need to be used by a single user in a single machine or a single place, then the best environment suggested is standalone environment. Here in the image you can see that BL, that is business layer, PL, that is presentation layer, and DBL, that is database layer. Everything in the single environment. Coming to client server environment. The environment contains two tiers. One is for clients and the other is for servers. The presentation layer and the business layer will be present in the clients and the database layer will be present in the servers. If at all the applications need to be used in a single building or a single place or in a single city by multiple users, application need to be accessed very fastly, and if there is no problem with security, then the best environment is client server or two-tier environment. Coming to web or three-tier environment. This environment contains three tiers. One is for clients, the middle one is for application server, and the other tier is for database servers. Presentation logic will be present in clients, business logic will be present in application server, and database logic will be present in database servers. If at all the application need to be used all over the world by limited number of users, then this is the best suggested environment. The last environment is similar to web environment, but number of application servers are introduced in separate tiers to distribute the business logic so that the load will be distributed and the performance will be increased. If at all the application need to be used by more number of people all over the world, then this is the best suggested environment. So this is all about session 3. So guys, to become a professional in testing, please do subscribe to our channel QA Tech and post your questions in the comment box. Thank you. Happy testing. Stay tuned to QA channel. So before closing my session, the agenda for the next session, that is session 3, is software process development model. So in this, the models I'll be covering is waterfall model, prototype model, evolutionary model, spiral model, fish model, and V model. So guys, stay tuned to QA channel. Let's meet in the next session. Have a nice day. Happy testing.